Okay. Hi guys. Wait, what is this? Thursday. Um, I know it's April. So looking at 5.3, we're going to look at molar mass and how everything connects. And so what I want from the curriculum expectations, how I'm marking you guys is if you succeed with curriculum expectations or not, okay? So I'm looking at if you can perform calculations involving chemical quantities to compare molar mass, moles, and number of particles for a given element and compound. Before I can get into this little diagram that I have here, I want to just go through the new formula. So the number of moles, N, is equal to mass divided by molar mass. Okay, and so this, if we're looking at our units, number of moles is MOL. Mass is always in grams. Okay, so chemistry likes grams, not kilograms, not anything else, grams. And molar mass is grams per mole. And you're probably thinking, well, where do I get molar mass? Let's look at an example. Let's look at carbon 12. Okay, so on the periodic table, you'll see something like, oh gosh, I think it looks like this. Okay, and the atomic mass, 12.00. We were saying from unit 1 that these are atomic mass units, that each proton and each neutron weighs 1 atomic mass unit. And I taught you in the last class a new number. Oh gosh, this would be, if you have exactly 6.02 times 10 to the 23 atoms of carbon, what does this turn into in terms of grams? 12 grams. So that's the power of Avogadro's number, is that when you have 6.02 times 10 to the 23 atoms of anything on the periodic table, the atomic mass, that before we were saying atomic mass units, is how many grams. So if 12.00 grams for 6.02 times 10 to the 23 atoms, which we also call a mole, this makes this unit here 12.00 grams per mole equals big M, molar mass. So when I'm looking at my formula, which hopefully you have a formula sheet, N equals little m divided by big M. Now, I had given you another formula with little n equals number of things divided by Avogadro's number. Because these two are exactly the same, we can make this relationship. But how do these two things connect? Okay, that's why I want to show you this little diagram over here. So this is an actual image of an atom. Okay, we can't really see the nucleus. We don't really understand the physics of the very, very teeny tiny of atoms. And so I call this the chemistry world. We can't see it. We can predict it. There's forces that exist in on the atomic scale that don't exist on the macro scale. And so the chemistry world, we look at it in terms of particles, in terms of atoms, in terms of molecules, and in terms of formula units. Okay, you've never seen an atom by itself. You'll never see a molecule by itself. We'll see these really grainy photos from an electron scanning microscope, but we still don't know much more than that. We live, I always say this is our world. We live in the big world, where if I said, can you go grab me a certain quantity of water, I would not say, can you go grab me 10 molecules of water. I would say, can you go grab me 10 grams of water? And that's because we live in a world where we measure quantities in terms of grams, in terms of mass. Okay, so how do we bridge our world, the world of the really big, with the chemistry world, the world of the really, really tiny? Well, this is where the mole comes in. This is where we're using the idea, the concept of this quantity of mole, or this quantity of atoms, this quantity of molecules or formula units that changes on our periodic table 12 atomic mass units to 12 grams per mole. With this number, 6.02 times 10 to the 23, we're able to take mass and calculate exactly how many atoms or formula units or molecules there are. So let's think about it. If we go from grams to moles, I just taught you this new formula, which is number of moles equals mass divided by molar mass. So if I have mass and I want to find out how many moles that is, okay, I'm going to divide my mass by my molar mass. If I have number of moles and I want to find out how many grams I have, I'm going to multiply by molar mass. Okay, so the formula is here, N equals mass divided by molar mass, or mass equals number of moles times molar mass. Okay, now before, if you had number of moles and you want to calculate how many particles there are, that was the other formula that I gave you. Okay, number of particles divided by Avogadro's constant. So if you have the number of moles and you want to find out how many particles that is, we're using this formula here. Number of moles times Avogadro's number. So I'm going to multiply it by Avogadro's number. And if I multiply it to get number of things, number of particles, if I have number of particles and when I want to find number of moles, then I'm going to divide by Avogadro's number. So that's why we go to the trouble of teaching you 6.02 times 10 to the 23, Avogadro's constant, because it's what is able to allow us to peer into what's happening on the atomic scale, how atoms and other particles react in actual quantitative amounts. We don't have to just rely on grams. We're actually looking at the number of things that are reacting. Okay, so that's going into, we'll talk much more about this in next week, but let's look at a simple question like finding the molar mass for each of these compounds. Right now we're finding the molar mass of ammonia. So molar mass is big M, and I put subscript NH3. And if you want to show your work, this is how I would show it. Oh, sorry, not 3, H. Okay. Otherwise, you don't really have to put this step unless you're calculating something gigantic like iron sulfate, and I think there's one even worse down there. But show me what you're calculating. 14.0 grams per mole. So if I have 6.02 times 10 to the 23 atoms of nitrogen, it weighs 14 grams, plus 3 times 1.01 grams per mole. Do this all on your calculator and you should get 17.03 grams per mole. Now, when you're calculating molar mass, don't worry about scientific notation, don't worry about significant digits, always put 2 decimal places. What I was telling you about scientific notation and significant digits, science, we always break rules for certain things. We like to see the molar mass of different compounds as they are. Okay, so I'm not going to change 17.03 grams per mole. But let's analyze what that means. The molar mass of ammonia is 17.03 grams per mole. which means if I had this in a lab and I put on an electronic balance, 17.03 grams, I know that I have 6.02 times 10 to the 23 molecules of ammonia. Why is it molecules of ammonia? Well, ammonia is a molecule. You can figure out how many atoms of nitrogen and atoms of hydrogen you have just by multiplying that. But in terms of mass, you would put in your electronic balance 17.03 grams, and you know that you have a mole. Okay. Let's see, so this one is just still calculate the molar mass of each quantity. So do you see where it says, now we have 3.0, I'm gonna do a different one. I'm gonna do B, just so that it's a little bit more complicated. It's giving you the mole amount that you have. So you know that you have 2.50 moles. And so you know that to find mass, let's go back to our formulas over here. I want to find M, so I'm going to rearrange my equation equals number of moles times molar mass. Okay, so over here, if I have 2.5 moles, it's going to be number of moles times molar mass. So let's calculate, before we can do anything, we have to calculate the molar mass of ozone. So ozone is comprised of 3 atoms of oxygen. So 1 molecule of ozone is 1 mole of molecules of ozone is 48.00 grams per mole, the molar mass. Now we have all the information to plug into this equation. And if you look at it, I always remember my formulas because I cross out the units. Because mole is on the denominator and mole is on the numerator here, if you cross out those 2 units and you're left with just grams. And because you're trying to find mass, mass is measured in grams. If you have anything else than mass, if you have moles on the numerator, if you have, if your grams cross out, anything like that, you know that you didn't do the calculation correctly. But because I've crossed out my units and I'm only left with grams, I know that it's correct. Okay, so let's put in our calculator, 48.00 times 2.5, I get 120. Let's follow significant digits. It would be 120 grams. Why? Because 1, 2, 3. And because this isn't molar mass, let's change it to scientific notation. Okay, this is the one I was thinking of. This is a pretty brutal one. I'll let you guys do that one on your own. Okay, other than that, I think that everything else is, I don't think I made you do these questions yet, determining the mass of each sample, where you have the number of formula units and you have to find the mass. Okay, so the first thing you have to do for this one is you have to find the number of moles. Okay, if you're working here, I'm going to use this color here. If you start here and you have to end here, you can't just do one step, go from number of things to mass. No, that would be too easy, unfortunately. So if you're here and you need to get to this part here, you have to go first, moles, using N equals number of things divided by Avogadro's number, and then you can go to grams. So mass is equal to number of moles times molar mass. Okay, so there's no way to jump straight from particles to mass. Let's look at this question here. This is asking for determine the mass of 6.02 times 10 to the 24 formula units of zinc chloride. let's first find the number of moles of zinc chloride that we have. So I'm taking the number of things, in this case formula units, and I'm dividing it by Avogadro's number. And because zinc chloride is a formula unit, this is going to be formula units per mole. This is going to be 10 moles. Okay, so I have 10 moles of zinc chloride. Mass is going to be number of moles times molar mass. So 10 moles times, okay, let's calculate the molar mass of zinc chloride. And I actually don't have zinc memorized. So let's look at molar mass of zinc. 65.38. And let me do of chlorine. It's 35.45. Okay, so I have 3 of them. And so I get, for the total molar mass of 1 mole of formula units of zinc chloride is 171.73. So if I have 10 moles, I'm just going to erase that. Let's look at how these units cross out. This mole is on the numerator, this is on the denominator, I'm left with grams. Perfect, that's exactly what I want. I'm going to go back to green. So now I can say that the mass is equal to grams. Okay, well, how many significant digits? I have 3 significant digits, so I can only keep 1, 2, 3 numbers. And I'm going to move the decimal place over 1, 2, 3 spots. So 1.72 times 10 to the 3 grams of zinc chloride. Okay, I hope that helps. If not, let me know and we can go through some other example questions.